Did you know that, according to the WHO, in 2004, nearly 11 million people worldwide were burnt so severely to require medical attention? Suffering a severe burn requires several intensive surgical procedures to treat the resulting wounds, often involving the grafting of new, healthy skin. Skin grafting requires the removal of a patch of skin from a healthy area on the patient's body, which is then transplanted onto the wounded area. Currently, new treatment methods exist that avoid the additional damage caused by cutting into healthy skin through the growth of new skin in a laboratory setting. This method only requires a few healthy skin cells extracted from the patient. However, creating a functional patch of healthy skin out of a few donor cells requires some time and a heavy amount of work by dedicated scientists. But even with the benefit of specialists, the results will vary from one laboratory to another. Without a standardized production method, errors may occur. Automizing the production of new skin cells would reduce these errors, leading to reproducible results and cost savings. The safe and effective treatment of burn victims is therefore more easily guaranteed. In that light, we introduce you to the SkinReactor, a machine custom-built to automate the production of healthy skin cells. The few skin cells you extract from the patient proliferate in the SkinReactor until there are enough cells to form a complete skin patch. To start the process, a lab technician places cell culturing fluids into the fridge and inserts a cartridge on top of the incubator. The cartridge is the core of the SkinReactor, where the cells are encouraged to multiply. As soon as the patient's cells are introduced into the machine, press Start, and the SkinReactor will take over. The skin cells travel from the insertion point through a liquid stream into the cartridge, where they attach to the surface and remain throughout the proliferation process. The skin cells need a specific environment in order to proliferate. That's why the cartridge is designed to cover the incubator, thus providing an enclosed and optimal environment for cell growth with a temperature of 37 degrees Celsius, corresponding to the natural temperature of the human body, and a 5% level of CO2. The incubator parameters may be adjusted as required for the specific patient's needs. Everything the skin cells need to proliferate will be provided by pumping a cell culturing fluid into the culture area. 12 valves and a compressor pump are used to carefully coordinate the flow and supply of fluids into the system. The environmental conditions in the culture area are regulated by a controller and monitored with a control panel. The precise amount of fluid needed is determined by calculating the weight of the fluid containers on a scale, using software that informs the operator when a container should be replaced. Although the process is automated, the lab technician can still check the cells using an integrated microscope, changing the parameters if necessary. Under these conditions, the cells proliferate as desired. However, the cell cluster stops multiplying as soon as it becomes too dense, meaning that fewer cells than needed are actually available. Our solution to this problem is a cell detaching system that removes the cells from the surface of the cluster and redistributes them over a larger area so that they have enough space to continue the proliferation process. Within 3 weeks, the skin production process is completed. Starting with only 50,000 cells, there are now 35 million healthy skin cells ready for the next step. To avoid cross-contamination between patients, the cartridge is thrown away after each use. The next step is removing the cells from the SkinReactor and forming them into a viable skin patch. Finally, the bioengineered skin is ready for transplantation. Thus, the SkinReactor will become indispensable for the safe and automated production of healthy bioengineered skin, ensuring better results in treatment for burn victims.